Welcome back to Kiersti's virtual classroom. This week we are talking about air pollution. All right, so first we're going to start talking about atmosphere as a resource, why we need the atmosphere, and why we need it to be clean. And then we'll talk about the types and sources of air pollution, where all of this pollution is coming from. So we have major classes, some sources of outdoor pollutants, and some urban air pollution. Then we have the effects of air pollution, and then how we try to control it in the United States. So atmosphere is one of our most valuable resources because it produces the air that we breathe. So our atmosphere is composed of 78% nitrogen, 20% or about 21% oxygen, 0.93% argon, and then 0.04% carbon dioxide. So our ecosystem services are blocking the UV radiation. So the atmosphere is blocking all of the UV radiation that is coming in. It allows some of it to penetrate, but it blocks a significant amount so that we don't get burned by the sun. It also moderates our climate, keeps our heat evenly distributed throughout the earth. And it also redistributes water in the hydrologic cycle. So this is the water cycle. So in order for the water cycle to exist, we do need the atmosphere, where we have atmospheric water vapor that has been evaporated from the surface of the earth and then forms into clouds, which then condense and form rain, sleet, or snow. All right, so some types and sources of air pollution. So air pollution are any chemicals that are added to the atmosphere by natural events or human activities in high enough concentrations to be harmful. So if these chemicals enter the atmosphere and they are not necessarily a harmful concentration, they're not necessarily considered a pollutant, or it's not contributing to the air pollution. Now, over time, when you add more and more chemicals, it does increase the concentration, which increases the likelihood of it being harmful. There are two categories. There's primary air pollutant and secondary air pollutant. Primary are harmful substances that are emitted directly into the atmosphere. And then secondary air pollutants are harmful substances formed in the atmosphere when a primary air pollutant reacts with substances normally found in the atmosphere or within other air pollutants. So when chemicals start to react in the atmosphere, those create the secondary air pollutants. All right, so here are some major air pollutants. We are probably pretty familiar with dust. The composition is variable depending on what the dust is being derived from. So these are solid particles. So anything that you breathe in that is from this pollutant is going to get into your lungs and be a solid instead of, let's say, a liquid or a gas. Then we have things like lead, sulfuric acid, nitrogen dioxide, sulfur dioxide, carbon monoxide, carbon dioxide. Methane is pretty familiar to most people. Benzene, and then we have the ozone. We'll talk about why the ozone is still important, although we don't want too much of it. And then chlorine. So these are the most common air pollutants. Okay, so where do these things come from? So this has the primary air pollutants and then the secondary air pollutants. Remember, secondary is a reaction with these primary air pollutants together or with the atmosphere. Okay, this kind of shows you where some of these things might come from. Our factories, burning, just having cars on the road itself. There's also natural sources, so volcanoes do produce carbon dioxide over time. So it's not just human-induced pollutants, but there are natural pollutants that do occur. So here are some major classes. We have particulate material, nitrogen oxides, sulfur oxides, carbon oxides, hydrocarbons, which I think are talked about probably the most. These are things from petroleum products like gas. And then ozone, which is O3, which is something you do not want to breathe. All right, so looking at particulate matter, these are thousands of different solid or liquid particles that are suspended in the air. So this could be soil, soot, lead, asbestos, sea salt, and sulfuric acid droplets. So this could be any number of things, but these are solid or liquid particles suspended in the air. Usually you can see these. So these are things that you normally, if you see it, you can kind of see it in the valley. In Fresno, we have a really bad particulate matter in the summer when rain hasn't knocked everything down, and you can see, I mean, you can't see the mountains, so you can definitely see that there are solid or liquid particulates in the air. And these are dangerous for two reasons. They can contain materials with toxic or carcinogenic effects, and extremely small particles can become lodged in lungs. So this is what I was talking about, you breathing that in. If you breathe in a lot of particulate matter, these are a lot larger than what your lungs can kind of handle as far as air quality goes, and it can severely damage your lungs. Looking at nitrogen and sulfur oxides. Nitrogen oxides are gases produced by the chemical interactions between atmospheric nitrogen and oxygen at a high temperature. So the problems here are it creates the greenhouse gases and it causes difficulty breathing, whereas the sulfuric oxides are gases produced by the chemical interactions between sulfur and oxygen. So this causes acid precipitation. Acid precipitation is not good because that means that the rain that's coming down is at a higher acidity point than before we had sulfuric acid in the atmosphere. So everything that hits the ground is going to be a higher pH, a lower pH than had it not have sulfur oxides in the atmosphere. So this is changing our rainwater, which changes the drinking water that we consume. So carbon oxides and hydrocarbons are a little different. So they kind of, most of these, as you kind of notice, they have to do with what they're called. So the nitrogen and sulfur have to do with nitrogen and sulfur oxides. And then the carbon oxides have to do with carbon monoxide. So gases of carbon monoxide and carbon dioxide. These are the greenhouse gases, and we know that this does block some of extra UV that we would need, and then it traps gases and warms the earth. So the greenhouse gases that kind of blanket the earth from the carbon oxides that are released end up holding heat closer to the earth, and that does not allow any heat to escape that normally would, and then we have a warming effect of the earth. Hydrocarbons are a diverse group of organic compounds that contain only hydrogen and carbon. So these are your smog air pollutants. So some are related to photochemical smog and greenhouse gases. So this kind of contributes to the same thing the carbon oxides do. And then we have the ozone. So this is tropospheric ozone. It's a man-made pollutant in the lower atmosphere. This is a secondary air pollutant, and it's a component of photochemical smog. We do have a stratospheric ozone, which sits higher in our atmosphere, further away from the surface of the Earth. And this is an essential component that screens out that UV radiation in the upper atmosphere. So the tropospheric ozone is bad because this is where the troposphere is the layer of Earth's atmosphere that's closest to Earth, and that layer is the layer that we breathe. And so if there's extra ozone or extra O3 that we are not supposed to be breathing, that is harmful to us and to other life on Earth. Stratospheric ozone, however, is much higher in the atmosphere, and this protects us from harmful UV rays. Problem here is that we have another pollutant that comes into play called chlorofluorocarbons, or CFCs, that are destroying the ozone. So particular parts of the ozone have been depleted significantly, and it's no longer protected in those areas at keeping some of the UV radiation out. All right, so let's look at some sources of outdoor air pollution. So two main sources are transportation and industry. So anything that relies on fuel, essentially, petroleum products, natural gas, those are creating significant air pollution. And intentional forest fires are also high. So the more forest fires we have, those create huge air pollution. We saw that with the creek fire last year. The air pollution was horrible in the valley, and if you went up into the mountains at all, it was bad. So you can definitely see when there are fires that occur what all of that smoke up into the atmosphere does to our pollution levels. So here about 57% of the sources come from transportation, 21% come from fuel combustion, and then 12% from the industrial processes, and about miscellaneous 10%. So urban air pollution is mostly the smog that we see. We see that mostly in summer when it hasn't rained and we haven't had a lot of wind to blow out the smog from the valley. This is what Los Angeles looks like a lot. Other areas that are very common to have these high urban air pollutions are places like China, other big cities that rely on petroleum and hydrocarbons to keep their economy going. So you often see this brownish orange haze that's formed from the chemical reactions that involve sunlight, nitrogen oxide, and hydrocarbons. So the formation of this photochemical smog is here. So we have the source of the pollutants, which would be nitric oxide, carbon dioxide, and the hydrocarbons. When those enter the atmosphere, there are reactions between the nitric oxide, the oxygen, and the nitrogen that's already there. And these can form things like nitric acid or PNAs. And then the carbon dioxide can react to form things like formaldehyde and other aldehydes. And then the hydrocarbons can also increase the oxygen gas and then increase our ozone levels. So some sources of smog in Los Angeles would be trucks, buses, and passenger vehicles. This would be about 53% of their smog source. Their industry, so manufacturing, oil refineries, and power plants are about 23%. Then their aircrafts, ships, and trains, 18%. And then as far as consumers alone, that would be about 6%. So in their home and the products that they use. So here's a case in point example. So we have Beijing on the left and Mexico City on the right here. You can definitely see the air pollution, the smog that has been created by transportation, use of hydrocarbons, use of nitric oxide. So this creates a very bad environment. You don't want to look through your cityscape and see all of this smog. I know that Fresno does basically every summer, and it looks really bad. And when we have forest fires in the Sierra Nevada, it gets even worse. And then in that springtime, February to April, it's just beautiful because the rain has knocked all of that down, and you can see the mountains, and it's gorgeous. And you kind of forget the rest of the year that we live kind of in a mountain town. We're, that valley town that's right before the mountains. And it's beautiful when you can see them, but most of the time our skyline looks like this, which is very disheartening. So if we use a little bit less hydrocarbons and nitric oxides, we can help decrease this significantly. And what was really cool last year in 2020 when we started quarantine, a lot of these areas were seeing a significant decrease in the amount of pollution in the water, in the air. In China, you could see your skyline. And then I know that in Italy, the canals started to clean up to where you could actually see through the water. It was actually really, really cool. And I hope that at some point we can maybe make that a routine thing. But one of the coolest things to see was that nature was able to bounce back from our horrible pollution that we do to it fairly quickly. We were only in strict quarantine in a lot of these countries for about a month, and the environment just kind of regenerated itself, and it was pretty amazing to see. All right, so some more effects of air pollution. So we have low level exposure will create things like irritated eyes and some inflammation in your respiratory tract. So your lungs will have a little bit harder time, but this can develop into chronic respiratory diseases. So this chart down here tells you, okay, so looking at this pollutant, what kind of source would this be caused from, and what effects might you see? I'm not going to read all of these to you. You can read them on your own time, but a lot of them have to do with irritated eyes and impacts to your respiratory tract. So that's one of the big things about air pollution, is that it affects your lungs. All right, some health effects of air pollution, some big hitters here. The sulfur dioxide and particulate matter irritate the respiratory tract and impair the ability of the lungs to exchange gases. Nitrogen dioxide causes airway restriction. Carbon monoxide binds with iron and blood, hemoglobin. So this is a little bit different than what you see with some of these other air pollutants. It can also cause headaches, fatigue, drowsiness, and death. And then ozone causes burning eyes, coughing, and chest discomfort. So all of this air pollution is a big deal because we breathe in air, and we want that air to be as clean and as natural as possible. So children and air pollution, you've probably seen, especially in the Central Valley, we have bad air days. I think that started in the early 2000s when we would get really bad smog days, and the air quality was so bad they didn't want kids outside. And so they would make these bad air days where you weren't allowed to do PE outside or do recess outside because they didn't want kids breathing in that air. So there is a greater health threat to children than in adults. Air pollution can restrict lung development. So because kids are still growing and trying to develop their lungs are not as efficient as at filtering out certain pollutants. So they can have more long-term damage than adults would. And children breathe more often than adults. If you've ever listened to a kid breathe, especially after they've ran, they're breathing in a lot of air. So this can also increase the pollution that they take in, which will increase their damage. Children who live in high ozone areas are also more likely to develop asthma. So you've probably been aware or had a family member who's had asthma, specifically because they live in the Central Valley. A lot of kids in the Central Valley have asthma, and then as they grow into adults, they don't really have it anymore. I am one of those. As a child, I had asthma, had an inhaler and everything, and then as an adult, I've been fine. So as their lungs are developing, a lot of times in the Central Valley, you'll see more kids with asthma than, let's say, in San Francisco or in Redding in Northern California. All right, so controlling air pollution in the United States is important. We want to kind of limit our impacts and find healthier, cleaner ways to run our machines, essentially. So some of the things like smokestacks have electrostatic precipitators on them, which is what this thing is on the right, and it helps kind of clean things out. This is without it. This is how much pollutant goes into the atmosphere. But nowadays, we try to control these smokestacks and lessen how much pollution is actually going into the atmosphere using these electrostatic precipitators. So when dirty smoke comes in, we have an electrode or a negative charge and a precipitator wall, which is a positive charge that will help clean out the gas, or clean out the dust essentially, and then all of that dust will fall off into a collector, and then cleaner gas will come out. So these little devices kind of help these smokestacks, which have been notorious for air pollution on industrial factories, at cleaning the air a little bit better before it actually goes into the atmosphere. And this is what it would look like with the electrostatic precipitator. So you can see the significant difference between without and with. So this will help your smokestacks kind of control how much bad gas or dirty gas will come out of these smokestacks. All right, so there is also something called a scrubber, which does essentially the same thing, but it's a little bit different. So here, dirty gas would go in, and then liquid water would come in to try to push down any of the sludge. So the water will mix with the dirty gas and kind of find all of the pollutant particulates and try to push it down into this polluted liquid sludge. And then clean gas would come out. All right, so other things that we can do is phase one vapor recovery systems for gasoline. So this is when we are extracting gasoline, trying to control some of the vapors that might be released into the soil and then into the atmosphere by using a series of different hoses to kind of control that. All right, so the Clean Air Act was a very important EPA law that was put into place that sets limits on the amount of specific air pollutants that are permitted. So there's 6 pollutants that they focus on. So that would be lead, particulate matter, sulfur dioxide, carbon monoxide, nitrogen oxides, and ozone. And we have seen a significant decrease in the amount of particulates, carbon monoxide, sulfur dioxide, organic compounds, nitrogen oxides in our atmosphere since the development of the Clean Air Act. So you have 2 things here, 1970 and 2006, 2 years, excuse me. And the green shows before the Clean Air Act, and the red is after the Clean Air Act. And all of our pollutants that we are focused on have significantly decreased. So this is really amazing to see, and hopefully we see this increase even more in the next couple of decades. So some urban areas with the worst air quality as of 2002 are extremes: Los Angeles, South Coast Air Basin in California, very severe Chicago, Houston, Milwaukee, New York, New Jersey, Long Island, the southeast desert of California, and then severe Baltimore, Philly, Sacramento, San Joaquin Valley. There's us, Ventura County. That says country, but that should say county. So that's Santa Barbara and Los Angeles. So we're not extreme, which is great, but we still make this list of the most or the worst air quality in the United States. So this gets regenerated every so often, and I can give you some links for what some of the newer data says. This is just from a textbook. So other ways to improve air quality would be to reduce the sulfur content in gasoline from its current average, which is 330 parts per million to 30 parts per million. Sulfur clogs catalytic converters. So if you don't know what a catalytic converter is, it's a converter on your car that helps kind of filter out some of the bad things that come out of your engine. And catalytic converters can be very expensive to replace. So if you clog it up with a bunch of sulfur because it's coming out of your gasoline, then you're going to have to replace it more often. Depends on the car, you have to. We can require federal emission standards for all passenger vehicles, including SUVs, trucks, and minivans. So this happens a lot in California. California is really good at creating these environmental standards and holding their citizens to it. A lot of people don't like it because it means that you have to pay you have to pay more fees at the DMV and things like that. So if you drive a truck, you have to pay more money because they're basically punishing you for emitting more hydrocarbons into the atmosphere. If you drive, a little beater car that's maybe a newer car that's a clean air car, they're going to charge you less at the DMV and for taxes because you're not emitting as much into the atmosphere. So this would be helpful on a more federal level because there's a lot of states that still don't do that. There's a lot of states that don't require specific emission standards for your vehicles. And then requiring emission testing for all vehicles, including diesel. So diesel has been kind of going away as far as personal vehicles go. I haven't seen as many diesels on the road as I used to when I was a kid. So I think less and less people are driving them, and more manufacturers are making their older diesel trucks more gasoline dependent. Um, and I just don't think people are driving as gigantic of trucks as when I was younger. And then ozone depletion in the stratosphere is something we've already talked about a little bit. But here's a visual for you. So the ozone, like I said, protects the Earth from UV radiation. Part of the electromagnetic spectrum with wavelengths are just shorter than visible light. So what happens is UV rays come in, and if we have a ozone at normal levels, you see a lot of bounce back, and it blocks a lot of it coming through. And so only in these like red zones here where we just have regular oxygen and not O3 or ozone, it will come in. So the ozone or the O3 helps block it. If we have reduced levels, you see a lot more of the UV radiation come through because we see a lot more of those oxygen O2 levels instead of the O3 ozone levels. So here's some images of the depletion. So the ozone thinning or hole was first identified in 1985 over Antarctica. And the reason that it's over Antarctica is because this is where the ozone was thinnest originally. So a lot of people are confused by this because Antarctica doesn't produce a lot of these chlorofluorocarbons that are depleting the ozone. But this is where the thinnest portion of the ozone began. So this is where the thinning has increased and become a hole. So like I said, this is caused from human-produced bromine and chlorine-containing chemicals, or the CFCs that I talked about. So the hole over Antarctica requires two conditions: sunlight just returning to polar region, and circumpolar vortex. So this is a massive cold air that circulates around the southern polar region, and it isolates it from the warmer air in the rest of the planet. So polar stratospheric clouds form, and this enables the chlorine and bromide to destroy the ozone. So effects of ozone depletion are higher levels of UV radiation hitting Earth, which can cause eye cataracts, skin cancer, weakened immunity, and it may disrupt our ecosystems and can damage our crops and forests. So we would like to recover the ozone layer. So in 1987, there was something called the Montreal Protocol that was set to help reduce the pollution of the CFCs, or the release of the CFCs, and we started using HCFCs, or greenhouse gases. So there was a phase out of all ozone destroying chemicals is underway globally. Satellite pictures in 2000 indicate the ozone layer was covering, and hopefully we'll have full recovery by 2050. So in the next 30 years or so, we will hopefully see full recovery of the ozone. So acid deposition, I've talked about a little bit, so that was like the acid rain. So sulfur dioxide and nitrogen dioxide emissions react with water vapor in the atmosphere and form acids that return to the surface as either wet or dry deposition. And so this is the pH scale that I was talking about. If we have acid deposition, we're increasing our acidity, and that will increase the acidity of our water, and we wouldn't want to drink super acidic water. We need a pH of 7 to 8 to be safe for humans. So this is how acid deposition develops. So we see power plants and industrial plumes, mobile emissions, and here all of that is reacting with the nitrogen in the atmosphere to form sulfuric acid. And then that wet acid deposition would be coming down as acid rain. And then we do see some dry acid deposition, which will come from the accumulation of those chemicals together to form a solid. And when that happens, it leads to increased acidity of the ground, the soil, as well as the water. So here are some effects of acid deposition. We see a decline in aquatic animal populations. There are thinner shells on the eggs of bird eggs, and it will decrease their likelihood of reproduction. So this is because calcium is unavailable in acidic soil. We also see forest decline. So in Germany, there has been about 50% of the forest, the black forest, has declined because of acid deposition. So here's a look at acid deposition and forest decline. So when we see acid deposition, excuse me, onto the surface, you see extra acidity in the soil, which will damage the soil and the fungi, and then impaired water and nutrients, which will then lead to root damage and death of a tree. So air pollution around the world is deteriorating rapidly, or well, air quality is deteriorating rapidly in developing countries. I've talked about China. In China, residents only see sunlight for a few weeks each year, which is super sad. I can't imagine, especially living in sunny California, what it would be like to only see sunlight a few times a year. And then in developing countries, they have older cars. They still use leaded gasoline. And the 5 worst countries in the world or the 5 worst cities, in the world are Beijing, China, Mexico City, Shanghai, China, Tehran, Iran, and Calcutta, India. So we didn't make the list, United States, but we're not far behind them. So long distance transportation of air pollutants. So these aren't just regional issues, they're global issues as well. So as the Earth rotates and as air masses take air from one area to another, these pollutants can also travel. So just because you are polluting in one particular area, air intermixes, and we have air masses that push air from one side of the United States to the other, and from one side of the United States to a different continent. So these air pollutants, can move along these kind of airways from one part of the globe to another. Indoor air pollution is something that a lot of people don't think about because you don't see it. Most of the pollutants are much higher concentrations, and most of them are things you cannot see. So the most common are radon, cigarette smoke, carbon monoxide, nitrogen dioxide, formaldehyde, pesticides, lead, cleaning solvents, ozone, and asbestos. So I used to work in the environmental field in Fresno, and we had a lot of indoor air issues, basically from either materials in the home, things that people would practice in the home, or soil from underneath the home. So unfortunately, if there are cracks in the foundation, if there is any air pollutant in the soil, so in the space between the grains of soil beneath the home or the building, that can come into the building and cause indoor air issues. And if you keep your home sealed all the time and there's no ventilation, you're going to see increased levels, and those things can cause long-term effects. A lot of these pollutants that I looked at will cause cancer over time. You need a long exposure, but in California we have very specific guidelines for how much exposure is acceptable, and a lot of times these places are not meeting that level, and so we'll have to come in and install big fans or better ventilation systems to try to get all of that air pollutant out. So this diagram gives you kind of a look at what kinds of things you might find in the home. If you've ever watched Hoarders, those are kind of the most extreme cases of what indoor air quality can look like when they allow like fungi and bacteria and black mold to develop in the home, or they've had a lot of rat feces in the home, and the person is usually very, very sick because of the living conditions. And so their indoor air quality is really bad, and they have to clean everything out. And a lot of times they have to knock down walls and kind of almost rebuild in order for it to be livable at a safe level. So here's an example of indoor air pollution for radon. Here are the cracks that I was talking about. So if there is a concentration of radon in the soil below and it finds its way through the cracks in the concrete, through different pipes, through foundation cracks in the walls, and it will escape outdoors, but you have to have the ventilation system. You have to open your windows. Otherwise, all of those gases will get trapped indoors. All right, so that is it for air pollution. We will talk about water pollution next week, and I will see you guys in the next video. Bye.